Hello, everyone. So we're going to start out here with Unit 1, slopes and rate of change. Now, I'm not always going to have this textbook that is open to the left. Again, that is the textbook. That is not your workbook. They are different. Though your workbook is on the right, your textbook is on the left. I'm just going to refer to it a little bit because I'm trying to emulate the skills that you should be having throughout this course. That said, we're going to get up and running here. So we're going to say this is 2025 key. Okay. So we're going to start out here with lesson one, which is rise over run. And this is both ratios and proportions and slope. The expectation is you have completed your essential skills booklet in module 0 before you come here. But I'm going to do this stuff anyways. So let's start out here. So before we go into what rise and run are, we need to understand what some of this other stuff is. So first off, what is a ratio? You should be writing this down as we go through it. Pause the video when you need, because I'm just going to go full force. So ratio is a ratio compares two or more quantities. So a ratio compares two or more quantities. What does that mean? Well, let's think, for example, if I give you 3 blue dots and 4 red dots. Well, this might be comparing the ratio of blue to red. Or we might do the ratio of, of red to blue. We might do the ratio of blue to total dots, or maybe the ratio of red to total dots. So for example here, if I'm saying what's the ratio of blue to red, well, let's think about this. I have 3 blue things and 4 red ones. So this first one here would be, it's 3 to 4. In case this isn't that clear, I'm putting these little 2 dots here. This shows our ratio. So there's 3 blue dots and 4 red ones. It's a 3 to 4 ratio. That's as simplified as I can get. Or if I go red to blue, how many red ones? There's 4 to 3. The order matters. How is the question asking it? Now these two things, 3 to 4 of blue to red, or 4 to 3 of red to blue, they mean the same thing, even though they're written differently. So how we write and read it is important. If we look at the ratio of blue to total dots, well, there's 3 blue dots, but there are 7 total ones. There are 4 red dots, but there are 7 total ones. Okay, so that's what ratio is. Now, proportion's pretty similar. Proportion says that 2 ratios or fractions, because they can be both, are equal. Proportion, there we go. What does that mean? So 2 ratios or fractions are equal. Here's a nice easy example. If I have a pizza dough recipe to feed 4 people, asks for 2 cups of flour and 1 cup of water. How much is required to feed 8 people? Well, that's not that hard, right? This is saying that, oh, if I need 2 cups, we're going to go flour. I'm putting a little F here, and water, putting a little W at the top. 2 cups of flour, 2. 1 cup of water, 1. Well, that's the feed 4 people. What if I want to feed 8 people? Well, 8 is just twice as many as 4, right? 8 people, I need to make twice as much food. So I'm just going to multiply them both by 2. So instead of 2, 2 times 2 is 4. I now need 4 cups of flour and 2 cups of water. It is the same concept, but the stuff you're going to see here is just going to be more difficult numbers. But the reason we use simple numbers in these examples and these recalls is because it's the same process. So as you go through this stuff, I want you to learn the process. Now, another thing is, think about if I give you a half of a cup of pizza. Sorry, half of a thing of pizza. Here we go. And I've said that, here we go. So I only have half a thin of pizza, right? Well, as a fraction, this one here is 1 over 2. But what if I cut it into quarters, but I still have the same amount of pizza? Well, it is 2 over 4. 1/2 and 2 over 4 are the same thing. In both of these cases here, you have the same amount of pizza. Okay. So, like I said, it's going to be the same process, but harder numbers. So for our first example here is we have a recipe for vegetarian chili. How much of it? It says that you need 56 ounces of chopped tomatoes, 30 ounces of kidney beans, 15 ounces of kernel corn. First question, what is the ratio of corn to kidney beans? Well, I can see that I have, and again, I'm going to go like C for corn, and I'm going to put B for beans because that's what's asking me. You don't have to do this, but it's a nice thing to do here. So I need 15 ounces of corn to 30 ounces of beans, right? But I can simplify those. I can simplify this a little bit. So maybe I can go down to 3 and 6. These are the same thing, just like the pizza. This is the same thing, just harder numbers. All I've done is I've been like, oh, I can divide this by 5 to both sides. That's all I've done here. I divided both by 5. 15 divided by 5 gives me 3. 30 divided by 5 gives me 6. They're the same thing. Now I can do it even more. I can divide them by a further 3. So now 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. So a 1 to 2 ratio is the same as a 3 to 6 ratio, is the same as a 15 to 30 ratio. They're the same thing. Now for question B, what's the ratio of tomatoes to kidney beans? Well, for tomatoes, I'm going to put T to a B. For tomatoes, I can see that it's 56 to 30. And again, you'll get better at simplifying stuff as it goes on. Your calculator can do it for you. I'll show you how to do that later in a calculator video. But so starting out here, I need to simplify these. Or can I simplify them? Well, they're both even. Let's divide them by 2, which will give you 28 to 15. These, again, are the same thing. Think about the pizza. All I've done is I've cut them both in half, divided both by 2. Now, sorry, that's supposed to be 28. Now, I can't simplify this any further, so that's what it is. So that's example 1. Now, example 2 here is saying that, hey, a big screen TV has an aspect ratio of 16 to 9. That's what modern day HD is. You are viewing this on a 16 to 9 screen. So for every 16 inches of width, there's 9 of height. What's the height of the TV? That's 40 inches wide. Oh, so now we got to apply it in a problem. So let's think about this. Starting out, I'm going to go width to height. Now, it's saying that what I take what I know. So first thing is I need to take what I know. I know that one of these ratios is 16 to 9. I know that for a fact. I also know that the width of one of these TVs is 40, but I don't know how high it is. So that's what I'm trying to figure out. So this is going to be something you're going to be doing throughout the next 4 months. So you're going to take what you know, you're going to find what I like to call find the magic number, and then 3 is you're going to apply it. So what does it mean? Find the magic number. Well, all I got to do is I got to figure out 16 times something gives me 40. Just like up here, 15 divided by 5 gives me 3, and this side divided by the same amount keeps that ratio in proportion. Just like up here, all I did was I times both of these by 2. I'm doing that same concept just with harder numbers. 16 times something gives me 40. So how can you figure that out? Well, work the other way. Go backwards. What's 40 instead of times divided by 16? Oh, it's 2.5. So this magic number here is 2.5. It works backwards, right? Just like I can double this, I can go backwards the other way. So those same concepts apply, just harder numbers. So 40 divided by 2.5 gives me 16. Well, then that means 16 times 2.5 must give me 40, which means the same holds true for the other side. 9 times 2.5 gives me, well, let's find out. Oops. 9 times 2.5 gives me 22.5. So my final answer here is 22.5 inches wide, or height. Now, you usually want to get into a good habit of circling your answer because you're going to come back in 4 months. You're not going to remember it as well. Circle your answer. Okay, so at this point, I want you to try these on your own. Literally pause the video and try the next 6 questions on your own. Use this if you get stuck. I'm just going to blast through it. So again, you should be pausing it now. I'm starting in 3 and in 2 and in 1. All right, question 1. In juice mixture, we have 750 milliliters of water mixed with 250 of juice concentrate. What's the ratio of concentrate to juice? Pay attention to the wording, concentrate to juice. So it's 250, which is the concentrate, and 750, which is the water. This is technically correct, but we can simplify this. A nice easy one might be, oh, I can divide these by 10. If you're good at numbers, you'll know immediately that this is divisible by 250. If you're not good with numbers, maybe not. So I'm going to divide these both by 10. So 25 to 75. I'm going to divide them both by 5. It's 5 to 15. I'm going to divide them both by 5 again. 1 to 3. So it's a 1 to 3 ratio. Question 2. To mix a certain shade of green paint, a painter mixes 2.3 liters of blue paint with 1.7 of yellow paint. What's the ratio of blue to yellow paint? Well, blue paint was 2.3 and yellow paint was 1.7. Now, one thing I want to say is only one thing should have a decimal. So only one thing should have a decimal. So I want to get these into a better, nicer ratio. So I'm just going to times it both by 10, which is going to give me 23 to 17. Sorry about that. I paused because I had to do a really bad sneeze and I accidentally stopped it instead of pausing. So again, we're on 1.1. I'm just going through these questions here. So question 3. Oops. Here we go. So question 3. A cereal mixture contains 6 cups of oats, 2 cups of almonds, 1 cup of raisins, and a 3/4 or 0.75 cups of coconut. What's the ratio of oats to raisins? Well, there's 6 cups of oats for every 1 cup of raisins, so it's 6 to 1 ratio. The ratio of almonds to coconuts is 2 to 0.75. There's only one decimal. We can keep it like that. What's the ratio of oats to the total ingredients of everything? Well, there's 6 cups of oats, 2 cups of almonds, 1 cup of raisins, and 3/4 or 0.75 cups of coconut. Out of those up, it's 9.75 cups of everything. So it's 6 cups of oats to a total of 9.75 cups of everything. This is the same as our ratio up here, the ratio of blue dots to total dots. Question 4. A dirt bike requires 15 liters of gas to be mixed with 4 liters of oil. If you use 20 liters of gas, how much oil will you use? Well, it's 15 liters of gas to 4 liters of oil. I take what I know, right? I know that there's this, but I also know that it's asking us if you use 20 liters of gas, how much oil do you need to use? So what we have is our usual question here. So same thing. Take what I know to find what I don't know. I know that 15 times something gives me 20, which means I also know that 20 divided by 15 divided by something gives me 15. So how do I find this something? How do I find the something? Well, take 20 divided by 15. I'm just going to put 1.33. We're going to have to round a little bit. That's fine. So, okay, so 15 times 1.33, close enough to 20, right? If I were to take this, add a bunch of threes in there, it'd get close. So we're just doing our best here. So 1.33. So 4 times 1.33, again, I can just put a bunch really well, gives me about 5, let's say 5.3. We don't gotta go crazy here. So it's about 5.33 liters of oil is what I need. Question 5 is, with 10 centimeters on a map is 25 centimeters of actual ground, how many centimeters would 45 kilometers actually cover? Now, I do want to make note of one thing. We are dealing with centimeters and kilometers. Normally, we have to convert. This is one of the rare examples where we don't. So take what I know. I know 10 centimeters to 25 kilometers is our ratio. I want to know, well, what about if it was 45 kilometers? How many centimeters would it be then? Same thing, right? 25 times something gives me 45. So 45 divided by something gives me 25. How do I find the something? I take 45 divided by 25. 1.8. So 25 times 1.8 gives me 45. Yep, it works, which means 10 times 1.8 gives me 18 centimeters. So it gives me the correct proportion, right? Just like how we multiplied a half to 2/4. It is the same concept, just harder numbers, okay? And then final one here is we have a recipe for corn chowder, which includes 3 cups of corn, 2 cups of water, 1.5 cups of cream. If we want to increase the yield of the recipe, the total amount, and we want to, instead of using 1.5 cups of cream, we want to use 4.5 cups. How much corn do we need? Well, this is a triple ratio: 3 cups of corn to 2 cups of water to 1.5 cups of cream. Well, I'm trying to figure out how much corn I need. I don't care about how much water I need. The question doesn't ask for it. And the only other thing I know is I use 4.5 cups of water. So just like before, 1.5 times something gives me 4.5. 4.5 divided by something gives me 1.5. So to do that, I start backwards, right? 4.5 divided by 1.5. Oh, it's 3, right? Some of you probably just noticed that from looking. So all I got to do is triple this. So 3 times 3 is 9. I need 9 cups of corn.